So this is example 11. It says to the nearest tenth of a unit, what is the approximate length of segment RS with endpoints at 3, -1 for point R, at 3, +1 for point R, and that's up here, okay, and at -1, -5 for S, and they want to know this length here, okay. So again, you could do, we're going to do the Pythagorean theorem, but the Pythagorean theorem in the distance formula. So let's write the distance formula down. Subtract the x's, and then subtract the y's. Okay, and the R value here was 3, 1, and the S value was -1, -5. Okay, and if I label it with my X's, it doesn't matter which you call first and which you call second. Let's just call this first. Whoops, that's a Y value. Made a big mistake. That's X1, Y1. This is X2, Y2. And when I do the distance formula, I don't want to forget about double negatives. So I'm going to kill all the variables, and all I'm going to do is leave space to write numbers in. So I'm going to write it in black. And I suggest you do this as well so you don't make dumb mistakes like forgetting double negatives. So I'm going to write it like this. I'm going to write it without any X's and without any Y's. And there it is there. So now I just have to put the X's in. Okay, so it says X2, there's X2, -1, and there's X1, 3. Okay, and then we've got the Y's, -5, and the Y's, 1. And so when I finish the problem, I'm going to get D equals square root of -4. But remember, the whole thing is squared. If you forget those parentheses and type it in the calculator, you are going to get messed up. Leave the parentheses there. Plus -6 squared, and keep the parentheses. Okay? -6 squared without parentheses is -36. -6 squared with parentheses is +36. That's just my little note there that if you're not careful, you'll get different answers, and you want the parentheses. So D equals, this is 16. -4 times -4 is 16. -6 times 6, -6 times -6 is +36. And that's 4252. D equals the square root of 52, which is approximately, I type it on the calculator, 7.21.